This is problem 73. The problem goes as such. A car accelerates at a speed of 2 meters per second for 2 meters per second squared for 6 seconds. It coasts at that speed for 2 seconds, then slows down by 1.5 meters per second squared for... Oh, where'd that time go? How long was it? Oh no, that just says how long is that custom there. Okay, it's asking how far apart, like basically what's that total distance, like cross. So, first part we know the initial velocity, that equals 0 meters per second, because they're speeding up. The initial point in the x-axis, which is 0 meters. We know it takes 6 seconds, and that they accelerate 2 meters per second squared. So knowing all that, we use this equation, which is the final x plus initial x plus initial velocity t plus 1/2 at squared. Plug in the numbers that are relevant. And that gets us 36 meters. Now we know it coasts for 2 seconds from there. So that means we need to first know, basically, like, what is the speed that they're coasting at? So we use this fancy equation of final velocity equals initial velocity plus acceleration times time. Initial velocity is 0, just acceleration times time. 6 times 2, that's just 12. So then just have that, times that by 2. So then we get 24 meters. And knowing, okay, so now we know that by the way, it's slowing down to a stop, the final part. So we know that the last velocity, I'm going to start writing it over here. Last velocity equals 0 meters per second. We know that the initial velocity from here equals 12 meters per second. We know that the acceleration is minus 1.5 meters per second squared. So then we plug in, final velocity squared equals initial velocity squared plus 2a times final x minus initial x. We solve for the final x, so this one right here, and we eventually get 48 meters. So then all it is just adding this together. We eventually get 108 meters.